Good morning, students. Today we are going to start with the third chapter of your book, that is Motions of the Earth, Rotation and Revolution. The names are very familiar to you. You have heard about them many a times before and you exactly know what rotation and revolution is. But here in this chapter, we'll go a little bit more further than whatever you have done in your junior years. So rotation, we all know, is the motion of the earth or spinning of the earth on its axis, and revolution is the motion of the earth around the sun. Apart from this, there is another motion of the earth which is called as precession, which is given on the first page of your book. And this precession is that when the earth spins on its axis, it wobbles in space. That means when the earth is spinning around its own axis, it is also shaking like this, and this wobbling motion is called as precession. It takes about 25,800 years for the entire earth to complete one cycle. Next one is your revolution of the solar system. Now this entire solar system revolves around the galaxy, and then the entire galaxy also revolves around the universe. Now these motions are so slow and they take so many years, that is why it does not affect our life, or it has no everlasting effect on our lives, and therefore we do not study much about them in the junior classes. Now let's start with the rotation and revolution of the earth. We all know that major two motions of the earth, one is rotation and the other one is revolution. Rotation means the motion of the earth around its own axis. It causes day and night. The exact time taken by the earth to move on or spin on its own axis, 23 hours and 56 minutes along with 4 seconds. This time period is called as a sidereal day, but we round it off as 24 hours, and therefore this one day of 24 hours which has been rounded off is called as the mean solar day, and this motion also causes tides. Next motion of the earth is revolution. Motion of the earth around the sun, we all know it causes seasons. It takes approximately 365 days and 6 hours. Though we take our year as 365 days only, we neglect these 6 hours for 4 years. They are added continuously for 4 years, making it complete one day. And this one day is an extra day in the month of February, and that year is called as a leap year. So this is what we mean by rotation and revolution. Now the spinning of the earth, let's take one by one in detail. We'll start with rotation first. Now we know that the earth spins on its own axis, and what is its axis? An axis is an imaginary line which is passing through the center of the earth, and it is not a straight line. It is tilted at an angle of 23.5 degrees with the vertical, and this tilt is called as inclination of the earth's axis. I'm showing you a diagram here. If you pay attention, this is a straight line if I divide the earth into two equal halves, and from the angle 23.5 degrees, this becomes the axis of the earth, the north pole on the top and the south pole at the bottom. So this tilted line is called as the axis of the earth. Now what does the straight line mean? Now this straight line is called as a circle of illumination. If the sun is on this side, it will give its light to this half of the earth, and the other half of the earth will remain in dark. So this side of the earth will experience day, and the other side of the earth will experience night. And in 24 hours, when the earth revolves, it comes back. So this side, which is night, will now face the sun and will have day, and this side of the earth, which had day, will rotate and go on to the other side and will have night. This entire procedure takes 23 hours, 56 minutes and 4 seconds, though we take it as 24 hours. So each part of the earth faces the sun at least once in a rotation of 24 hours, and that is what we call as rotation. Now this line, this is an imaginary line again. If the earth would have been straight, this line is called as the circle of illumination. That means this demarcates the day from the night. So if you see carefully, The entire North Pole in this position is in night, and the entire South Pole in this position of the Earth is facing daylight. When the situation would reverse, when the entire Earth will rotate, then the North Pole will be in light and the South Pole will be in dark. So this is how the circle of illumination and the Earth's axis works. The same diagram is given in your book also, if you see clearly. I made it a little simpler, but this is what it means here. Now, always remember, whenever you're making the diagram of the Earth, you always have to point the North Pole towards your left. That means no matter whichever position the Earth is, if you look at this, no matter whichever position the Earth is at, the North Pole is always facing towards the left hand side, and this property of the Earth facing towards one side of the North Pole is called as the parallelism of the Earth's axis. The Earth's axis is inclined by 23.5 from the vertical plane or 66.5 with the plane of its orbit. It never changes its direction, as it always points the Polaris or the pole star throughout the Earth's revolution around the Sun, and this is known as the parallelism of the Earth's axis. So these are certain things which you must underline in your textbook so that you remember what exactly is these terms. So you should know what rotation is, you should know what the axis is, you should know what the circle of illumination is, and you must know what does the term parallelism mean. So the imaginary line demarcating the day and night is called circle of illumination. Now when the Earth is revolving around the Earth, that path which the Earth takes to revolve around the Sun is called as the orbit, and it is elliptical in shape. That means neither it is oval nor is it a complete circle. It is elliptical in shape. Now there is a time when the Earth is nearest to the Sun and a time when the Earth is farthest from the Sun. So when the Earth is nearest to the Sun, we call that position of the Earth is perihelion, and when the Earth is farthest from the Sun, we call that position of the Earth as aphelion. Now what is the difference between the two? Nearest, farthest. Now this has nothing to do with your summers or winters or hot or cold. These are just two positions of the Earth which the distance is demarcated as. So in perihelion, it happens when the Earth is the closest to the Sun. It happens on January 3, and the Earth is 147 kilometers away from the Sun. The aphelion position, when the Earth is farthest from the Sun, happens on July 4, and the Earth is 152 million kilometers away from the Sun. When the Earth is at the perihelion position, it is rotating the fastest, and when it is at the aphelion position, it is rotating the slowest. That is just because of the pull or the force between the Sun and the Moon. Now, these two topics, or rather these pages, that is 1, 2, and this perihelion and aphelion, the leap year, the orbit, this we have done. Revolution of the Earth also you've done. So we have completed approximately 4 pages. I would like and request you all to go through these first 4 pages of your book. Get back to me in case you face any problems or you have any doubts, and then we'll take the chapter further from here.